what I'll do when I'm sick. I'll probably wear a mask. You can do what you want. I know last year we started to switch over, right? Sometimes people would come to class and they'd be coughing and we're over it. Where the previous year, we weren't over it. Someone coughed in class, we all looked at them like, yeah. I'll try and wear a mask if I happen to get sick. I don't usually. I'm not sick today, so if you hear my voice give out, it's just because I was coaching hockey for 2 hours on Saturday, and that's a lot of yelling, and so my voice is on the edge. I'll do my best, okay? I apologize to anyone watching this on a video. You might have to hear me get organized. Okay, exponent laws part 2. Seems pretty straightforward. You're like, oh, exponent laws. I'm not bad at exponent laws. Wait till you see when this gets out of hand. There's an example where this lesson switches from like, oh yeah, no problem, to, oh boy, here we go. Okay? Exponent laws part 2. Recall the following exponent laws. So I'm going to bring up the old exponent laws in here, so you've got those ready to rock and roll. Here are the exponent laws. I'm now calling it product law. I think I called it multiplication law on Thursday, just not to scare anyone off. Multiplication law. Well, it's technically called the product law, and product just means multiplication. And here's the product law. The product law says if you've got something, some power, a to the m, and you're multiplying that by a to the n, bases the same, then you can just add the exponents. That's the story with exponent laws so far. The next one, a to the m divided by a to the n, so it has to be the same base, and I don't have another law coming for when they're not the same base. When they're not the same base, there's nothing we can do. But when you work in applications, often it will be the same base. You get a to the m minus n. Hopefully this part is all familiar. Little rule here though. A can't be equal to 0, and more about that today. We'll talk a little bit about division by 0. Then we'll sneak up on division by 0 and start talking about why we can't go divide by 0. And then power of a power was the third law. If you've got a to the m, but then an exponent outside that brackets, you can multiply the two exponents together. And I talked about why these rules exist in the other lesson. That is, I explained that these are not magic. They're not math tricks. These are math shortcuts straight from how numbers work. Okay? Are we okay so far? I wanted to review those. As far as exponents part 2, we better get exponents part 1. That was exponents part 1. Today is exponents part 2. Are there any questions about those 3 laws? Do you need more time? Can you hear the difference in my voice today? I'm not from the hockey coaching, because it hasn't started to give out yet, but how slow and measured I am. I can feel myself being a little worried about this lesson. I hope that brings your attention in with me, where you're like, whoa, he's a little worried here about explaining this right. I better listen carefully to get this down pat. Good? More time? You let me know. Just wave your hand in the air like this if I go too fast past something, okay? It won't bother me at all. Now some extra laws that will actually help. I'm going to highlight that in just green, just to tell you, these will actually help you. If you didn't have these laws available, things would take forever. That's what exponent laws are all about. These questions are going to take forever if every time I do one I have to write out all the exponents. This will make things easier. Consider the following. Say I've got, turn off the highlighter, okay. 2 times 3, and that's all to the exponent 4. And like I did on Thursday, I'll write it all out. Do it the long way, hoping to find a shortcut here. If I was to write that all out, I'd get 2 times 3 times another 2 times 3 times another 2 times 3 times another 2 times 3. If I multiply that all out and do it the long way, I get a whole bunch of 2 times 3's multiplied together. And because multiplication is friendly, what we say is it's commutative, we can do multiplication in any order we want. What I mean by that is my kids are learning their times tables right now. And they're figuring out that you only have to learn half as many as you think you do. 5 times 7 is the same as 7 times 5. It doesn't matter which way you do multiplication. So for that reason, I'm going to reorganize this and say I'm going to put all the 2's together. 2 times 2 times 2 times 2. And then all the 3's together. 3 times 3 times 3 times 3. Why would I do that? Because it allows me to collect them back up again. How many 2's are multiplied together? 4 of them are multiplied together. And how many 3's are multiplied together? 4. So I get 2 to the 4 times 3 to the 4. Allowing us to have a shortcut. If what's inside is a product, and if you're bored, listen to my words carefully. If what's inside is a product, only if it's a product. If it's a product, can you see the shortcut? How could I have got from the first line to the last line without writing it all out? What happens with the exponent 4? It just goes to each one. Yeah? So each one. So here it is in a law form. If you've got two things, A and B, with some exponent out there. Is this easier to understand? No, but it's handy for studying, folks, to write it down like this, to go, if I've got two things multiplied, only if it's multiplied. This doesn't work for addition. That's what should upset you about this lesson. It doesn't work for addition. But if it's multiplied inside, then each of them can just have the exponent. It's a lot like distribution. It is a distribution situation. That is, if it's a multiplication inside and an exponent outside, you can distribute the exponent. Now, if your brain's already starting to muddle up like, oh, this only works sometimes but not other times, and the other distribution, yeah, I know, I've got a sentence I've got to write at some point. I'm going to write it in gold. I switch to the color orange and acts like it's gold, and I'm like, here's a gold sentence. If you write nothing else on your study sheet, write this down, and I'll help you manage these distribution situations. Good news. If it's a product with an exponent outside, each one gets an exponent. You should be able to do that shortcut nicely. Okay? If it works for product, it's going to work for quotient. Product and quotient, multiplying and dividing, they're very similar operations. They work together well. Just like addition and subtraction, very similar operations. Okay? Oh, do you need more time there? No? Same thing with division now, and it's going to work. There's going to be a nice shortcut. Let's say I did 2 over 3 to the power of 4. I'm using very similar numbers here. And the reason I'm using similar numbers is it's a teacher trick that I'm hoping that when you get to the homework or get to a quiz or a test, you sort of remember my example because I used similar numbers. So if I had 2 over 3 times 2 over 3 times 2 over 3 times 2 over 3. When I multiply those all together, I get in the numerator 2 to the 4 over 3 to the 4. And do you see the shortcut when it's a quotient inside? I know I'm using the quotient word now instead of division. Quotient means division. You know, you're dividing two things. And again, it's a distribution type situation. That exponent of 4 can go on the 2 and go on the 3. Very nice. It leads people to immediately decide, yeah, every time you ever see anything, you distribute. And that's not true. My gold sentence is almost here. I'm going to write something in gold. And if you write nothing else down today, you should be copying every word I say, everything I write. If you write nothing else down today, you should write down the gold sentence. Because even if you got 100 in 10 academic, this is going to trip you up if you don't recognize when can I distribute and when can't I distribute. Okay? Because this is powerful stuff. And easy to do. Once you know to distribute, it's pretty easy to do. Bang, just put the exponent on everything. Here it is in fancy language, fancy symbols for easy memorization. This is the understanding. Here's the memorization. If you have A over B, and that has an exponent of m on it, you can take the exponent and put it on the numerator and put it on the denominator. Although I do want to ask, is anyone really up to speed with this notation? Because there's a little rule here. This one has a little rule because there's division. There's a little restriction here about the numbers. Does anyone know what the restriction might be? What can't happen here or this doesn't work? It's okay if you don't know. I bring it up just so you start to think about, is this always true? Does this always work?
Isn't it equals 0?
Which part?
If like A or B equals 0.
A can be 0. We can take a 0 and divide it by something. That was allowed. In fact, you might have liked that in lower grades. When 0 was involved, you're like, answer's 0. It seemed like when 0 was involved, the answer was always 0. But that denominator can't be 0. Don't get too excited about that yet. Just use that as a for now. That's not really what I'm trying to teach today. But we do mention it to go, careful now. B can't be 0 or this doesn't work. And here's the gold sentence. Gold. Gold. Write this down. And for you highlighter people, for you iPad people who have a special way to write these things, this is the one where you get to highlight or you get to I keep these around, a set of these 4. My daughter, who's in university, tells me these are the best ones, this little set of 4. She's got a method of keeping track of things where while anyone's teaching, any class she's in, she's got her 4 highlighters ready to go, and she's got a color coding system. I don't know what her color coding system is. But I can tell you it's sort of like this. Blue is, put that on the study sheet. Yellow is, I didn't understand that. I'm going to have to ask the prof about that later. Orange is like, make sure you copy this into your other set of notes. And pink is like, I'll need this for the homework. I don't know what it is exactly, what her system is. But she's got a system so she can look back at her notes and know what's going on. So it's not just a big muddle of stuff. Gold. I'm going to write it in gold. And then I'm going to highlight it for you potential highlighter people. I keep some of these around. If you're dying to have some highlighters because you love what I just said, come and see me. You can have some of my highlighters. Gold sentence. Oh, a line first. A line. This is your brain trying to sort this all out and go, okay, so where are we at with this distribution thing? Gold, 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 gold. Exponents. Why is he slowing down? I want this sentence to be as short as I can and still have the ideas in it. Exponents distribute. Over multiplication. Or division. Yes, that's good. Highlighter. What highlighter will I use? I'll use red. When I'm doing on the board, I always use red highlighter. When I'm like, hey, sleep through the rest of the lesson. Yeah, take a complete nap and ignore everything else. But you better have that. Is red, is that too hard to read now? Yeah, I know. So I'll red highlight it underneath, okay? I really want to, I lost some stuff. One last word. I didn't put a period there. One last word. The most important word. Only. This doesn't work when it's add or subtract. Your brain explodes. You're like, wait. Distribution was over add or subtract. Here comes the second gold sentence to tie together with what you already knew. Multiplication or division. Distribute over addition or subtraction. That's the other distribution we did. And if you're right with me, you're like, oh, that's why we distribute when it's addition, but we don't distribute when it's multiplication using multiplication or division. But with exponents, it's the other way around. With exponents, you can do it with multiplication division. but you can't do it with addition and subtraction. Some examples coming to see that. I've never studied for math before. You keep mentioning this study page. I refuse. I got to memorize all these history things. I got to memorize all these biology things. Now I got to study for math too? Yes. Even if you got 110 academic, you're not smart enough. You're not smart enough just to have all this stuff and just listen to my lessons. I'm not good enough teacher. You know, unless I was able to do some kind of Vulcan mind meld thing where I just, and all the information from my brain download it into your brain. I can't do that. So we're going to have to study. You're going to have to make a study sheet. Hours and hours of poring over this stuff? No, but the day before the quiz, you're like, when can you distribute? And you're like, okay, exponents, multiplication, division, yeah? Multiplication, addition, subtraction. Okay, good, got it. Or else you're going to get yourself in real trouble trying to juggle all this stuff and keep track of it all.
Where it says multiplication and then under
Or division.
so it's multiplication or division.
Yeah. She asks about that word that I used there. And let me give you an example of what you were supposed to know before today. So if this is a little foggy, you might want this. This is what you were supposed to know coming in today. If I've got a 3, I don't want that gold. I want you to be able to see this. Very good. If you got a 3 out front of an x plus 2, it distributes. Yes, did we do a bunch of those where you're like, yeah, I remember that now. But it works for division as well. If you had a 1/3 out there, it works for division as well, even though it's usually a multiplier that's out there. Here's what you can't do. In red, here's what you can't do. 5 times xy is not equal to 5x, 5y. No. We don't distribute when it's multiplication inside. And if I finally got your attention, we're like, oh, I see what you're trying to say today. If it's addition or subtraction, yes, distribute. If it's multiplication, don't distribute. That does not work. It's not a math, torture you type rule. It's this is the way numbers work. Okay? And what did we learn today now? Today, we learned that if it's x times y, and there's an exponent out there, yes, we do distribute. Everybody gets a 5. Yes. But if it's not multiplication inside, if it's x plus y to the 5, no, don't distribute. This does not work. It's not because Mr. Todd is trying to torture you. It's not because math hates you. It's because that's the way numbers work. You won't get the right answer. The numbers won't be correct. Now that's a good page of mathematics. That might be better than my gold sentences. This is like, your sentences messed me up. You're like, okay, let me show you with examples what you can do and what you can't. In fact, most things don't distribute. I think I've shown you almost all the distribution there is in mathematical anywhere. 2 situations that you're allowed to distribute. 2 only. Exponents when it's multiplication or division inside. Multiplying when it's addition or subtraction side. That's it. That's all the distribution. Then we send you home, we make you do 500 questions of homework, and you think everything in the universe distributes. No, it's very specific examples. There's very specific situations where you can distribute. Whew! Big. All morning I was like, save every ounce of energy, Rob, and for that moment, that teaching right there. The rest of it is examples, but that's the important moment. Question?
Can you go back to the examples?
Yeah. Examples. This is why the videos are fun afterwards, right? Videos afterwards, you're like, I got most of it. But when he's talking about that part, I got a little confused. Then you can go re-watch that part of the video, stare at the wall for a while, send me a text message, or send your friend you'd snap your friend, would you? Send a little snap to your friend and go, did you know what he was talking about right there? Okay. You want me to discuss math after I leave class? You better get to the bottom of this stuff and not just believe, I'll remember it in the test, it'll be all right. Not anymore, it won't. Never again will it be all right. We must do better. Did that give you enough time? I'm going to do examples like this. So if it's like, still a little foggy, that's what my examples have worked at. Now I'm going to do a bunch of homework type examples. Here's what you'll see in the homework, and then I do a bunch of them on the board. Okay. Good. All right. Back to here. On we go. Examples. Okay, make those bigger. Make those bigger. Make those bigger.
Mr. Todd knows.
Yeah. This is when your brain really turns on, right? Where you're like, okay, this is what he's going to ask us to do in the homework. Question 1A in the homework probably looks something like this, and this is what I have to accomplish. And this is what I hope I've got through to you. You see a question like this, and you see exponent on the outside, and you pause. And you go, okay. Mr. Todd says, if it's multiplication or division in the brackets, I can just distribute. Won't I be happy? Distribution's easy to do. It really is easy to do, if you're allowed to do it. That's when you get messed up, is when you do it when you're not supposed to do it. So you're crossing your fingers like, okay, there's an exponent out there. Let's hope it's a whole bunch of stuff multiplied together. And it is in this question. It's a whole bunch of stuff multiplied together. So if you know that, what you do next is pretty easy. You distribute the 5 on everybody. -3 gets exponent 5. X squared gets exponent 5. And y cubed gets exponent 5. And then you get your phone out and you go to the Pizza Hut app and you order a pizza because you're like, hey, I'm home free now. I did the important first step. Because this stuff, you're supposed to have done your other homework, and this is supposed to be pretty straightforward. -3 to the power of 5. Well, you might need your calculator for that one. -3 to the power of 5. I'll try and do it in my head just to try to stay young. Too late, Mr. Todd, you say? Well, I'm going to try and keep my brain young. 3 times 3 is 9. Times 3 is 27. Times 3 is 81. Times 3 is 240. I'm doing distribution, by the way. 243. I'm going to make a mistake here on purpose. You get ready for it, okay? This is the old exponent laws. X squared to the power of 5 when it's power of a power. Do you already feel the laws running together on you? This is why the study sheet. You want to be able to go, bang, power of a power. What do I do with the two exponents for power of a power? I didn't hear what he said. My hearing's not good. Let's multiply them, right? But you want that like this, right? That's why the study sheet. You want it to be like bang, bang, bang. Otherwise, you get your test back and you're like, oh, I knew this. Oh, I knew this. Oh, I knew this. If you ever had a test like that, you're like, wait a minute, I knew this. It all ran together in me. Study sheets is the answer. Or you say, oh, I blanked. You didn't blank. You forgot to study.
Isn't that supposed to be a negative?
Yeah. Yeah. Odd power, I would have ended up with an extra negative in there, yes. So this is x power 10. And this one's y power 15 because I multiply the exponents. So I've got these four. Again, it's the cat in the hat type stuff. This is cat in the hat homework. It's not an accident that my cat in the hat book is here. It's a life lesson, and it's also an algebra lesson. Where is he? Where is he? There's you doing your algebra homework. Exponent law 1, exponent law 2, exponent law 3. You're holding them all up and trying to balance them all with a smile on your face and a song in your heart. Oh, what happened? I set the cat in the hat on my controller and changed pages. Can I do anything more than this? No. These are unsatisfying answers. Okay, so what's the answer? Like, no, these are simplification type answers. We'll get to getting answers. Yes, we will. But for now, it's like, okay, this is much better than this. The x's all have their individual exponents on them. Okay? For you computer coders, one of the reasons we do this is number of operations. This, if I was to plug x and y's in this, I'd have to do 1, 2, 3, 4, 5, 6 operations. In your computer, this is only 1, 2, 3, 4 operations. It'll get better and better as we move through about how much better we'll make the coding if we do this. Okay, next question. I also want to note from here on in, there might be multiple ways to do these questions. that give you the same answers. There's different steps you can take here. So, the exponent laws are bouncing around in my head. I see an exponent outside the brackets, and I need to tell you, when I look at this question, if you could see inside my brain, that's what I see. I first go, oh, there's an exponent outside this mess. What I know about exponents from my 2 laws today is exponents can distribute as long as what's inside is multiplication or division. So that's what I'm hoping for. I hope it's all multiplication or division, or the story's over. When I finish this example, someone have the bravery to go, what if it's not multiplication or addition or division? And then I'll explain that so you can see the perspective. A lot of the homework today, it's like, yeah, it works. This is exactly for this situation. This is all multiplication division, so the exponent can be distributed on everything. So this is 4 to the exponent 3. A cubed to the exponent 3. B squared to the exponent 3. 5 gets exponent 3, and B to the power of 4 gets exponent 3. If you're like, I totally get that, I don't know what he's talking about, I'm not going to have to do this homework. Get yourself a pillow because you're dreaming. You have to do this stuff. Watching me shoot baskets from the line all day does nothing as far as getting you ready for the game, the test. Yeah? Well, then your old exponent laws kick in. 4 to the power of 3. Okay, 4 times 4 times 4, that's 64. A cubed cubed, power of a power. It will get faster. First few questions you're doing for homework, these take forever. You'll get faster at them where you just go, okay, a to the power of 9 and b to the power of 6. Maybe you're really good at this already. And you think you can jump from this to this. I don't know. Scary. That can be scary. It's easy to miss a step when you do that. And then I get 5 cubed, which is 125, and b to the power of 12. Look at me, look at me, look at me now. It's fun to have fun. But you have to know how. I can hold the cup and the milk and the cake. I can hold up these books and a fish and a rake. I can hold the toy ship and a little toy man. And look, with my tail, I can hold a red fan. I can fan with the fan as I hop in the ball. Miss Todd, you've read that before. Well, yeah, I've had 4 kids. Me and this book have done a few laps. But that is not all. Oh, no, that is not all. Can you see what else has to happen here? What else has to happen here? Subtract the exponent with the b's. And we're about to step in a giant mouse trap, bear trap. Ka-choing! Something bad's about to happen here. Hopefully you can see what's about to happen. So let's just isolate the situation here. 64 over 125 does not reduce. There's nothing I can do there. And there was no a's in the bottom. So there's nothing to talk about with the a's, but we just got to take a second and talk about the b's and get really afraid for a second, okay? We got to talk about the b's. And I'm not going to charge you extra for talking about the b's. This will be a freebie. Subtract the exponents. What's the problem? 6 minus 12. Negative exponents? Negative 6? What am I supposed to do with negative 6? I'm going to write that up here and go b to the negative 6. What am I supposed to do with that? You might want to write this down. You might want to write this down separately. What do I do with negative exponents? Well, I'm going to think of it a different way for just a second to be able to handle b to the negative 6 and make you go, hopefully, when I'm done, if I've done my job, you're going to see what I do and go, oh, okay, that's no problem. Okay, here's what we do. Let's just imagine the b's for a second. b on the top, b to the 6, b, 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 b. Basically. Then the bottom b to the 12. B, 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 B. That's what's really going on here. Are you telling me I got to write all the B's every time? No, no, no. We got to understand what's going on with the B's. How many B's cancel if there's 6 in the top and 12 in the bottom? 6. That's not hard. Cancel, 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 cancel. Cancel, 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 cancel. How many B's are left? 6 B's. But where are they? In the denominator. That's all b to the negative 6 is trying to say. That could be the end of discussing negative exponents. I'm going to talk about them more today, but that could be the end of the discussion about negative exponents, is it just means they go down the denominator, that's all. The battle was on between numerator b's and denominator b's won the battle. And so if I were just to subtract them, you can do that actually. You could write b to the negative 6, and then in the next line write, move it down to the denominator, b to the positive 6. Yeah? A positive exponent means multiply by something. A negative exponent means divide by something. More on that coming up. I just threw that in there just to go, just in case you think this is easy, there's a little more to the story before we're done. But are there any questions? We're going to be close on time today, let me tell you. But I'm not going to rush it. We're going to take our time on this. Do you need more time there? No? Well, to get to negative exponents, we're first better talk about the 0 exponent. What happens if there's a 0 exponent? I don't know if this was talked about very well in grade 9 and grade 10. So I'm going to build a beautiful table. I'm worried about the color orange and whether you can see it or not, but you can imagine this is all in gold. This is great, great mathematics. This will be the best thing I show you all week, by far. Let's talk about 3 to the power of 5. That's 3 times 3 times 3 times 3 times 3, which 3, 9, 27, 81, that's 243. Stick right with me so you see what I'm up to here. See what the plan is. Someone says, how do I figure out what 3 to the 0 is? I'm like, well, I'm not sure what 3 to the 0 could possibly mean, but I'm going to get it this way. I'm going to look at what 3 to the 5 is. Then I'm going to look at what 3 to the 4 is. That's 3 times 3 times 3 times 3, which is 81. Can you see the plan? I'm going to figure out what 3 to the 0 is by going, I'm going to count down. 5, 4, 3, 2, 1. And then hopefully, at the end, I'll be like, oh, I know what 3 to the 0 has to be. 3 to the 3. 3 times 3 times 3, 27. 3 squared. 3 times 3, which is 9. And then the first sort of difficult line, maybe, is 3 to the 1. 3 to the 1 just means you got a 3. Now, we need somebody clever who's not going to get intimidated by this to go, okay, that means 3 to the 0 has to be a certain value. Does anyone know what the value has to be when I do 3 to the power 0? It has to be 1. How did you know it had to be 1? He just guessed. Can you see in the table what happens here? To get down each step in the table, I'm taking off a power of 3. I'm dividing by 3. I'm dividing by 3. I'm dividing by 3. And then I'm dividing by 3. Every time I go down a step in my little table that I built here, I'm dividing by 3. And if I'm dividing by 3 every time, when I take 3 and divide it by 3, the answer must be 1. Now that blows some people's brains up. They're like, whoa, hold on. How can something with exponent 0 be 1? Well, I can phrase it a different way. If I'm doing 3 to the exponent 0, it means I'm multiplying by 3 no times, and that's like multiplying by 1. Here's a potentially better explanation. The only way that 3 to the 0 can happen is if you're dividing something by itself. So someone could come home and do their homework tonight and end up with 3 to the power of 5 divided by 3 to the power of 5. If they use exponent laws, they'll get 3 to the 0. But somebody else goes, I don't need the exponent laws. It's something divided by itself. It must be 1. So to alleviate your concerns about the exponent 0, the only way the exponent 0 happens in real world math, the only way it can happen is if something got divided by itself. So that's why the answer is 1. Are there any questions about the 0 exponent? Oh, I need a little box here. After all that, all you really need is another exponent law. A to the 0 equals 1. That's the nicest exponent law there is. Exponent 0, answer 1. Now, this is, you don't even have to write this down if you don't want, but I'll write it down because technically this only works if A is not 0. Then it would be 0 to the 0, and what the heck could that mean? We'll just leave that one on the shelf for a bit. We'll just leave 0 to the 0 on the shelf for a bit, and we'll get back to it a little bit later. Question?
So if it's like, let's say it's just like 3, like there, it's like 3 to the power of 0 or whatever.
Yeah.
It would just be 3. Like it would just be the number 3 at the top.
3 to the exponent 1
Yeah, but okay.
is just 3.
3, okay.
3 to the 0 is just the number 1.
What's the difference if it's like a variable? What if it's like
Anything with exponent 0
it's just 1?
is just 1. The only way it can happen is something got divided by itself. So, a quick example underneath. Example. We love this one. Virtually every teacher I know of loves putting this on the test because they think it's hilarious. I don't know if it's hilarious or not. You can decide if this is hilarious to do to students. X squared y cubed all to the power of 4 plus xy all to the power of 9 minus x to the exponent 0. Math teachers think this is hilarious because students all go, ah! But the answer is, because it's got an exponent 0 on it. Exponent 0 is the giant trump card. It's like, boom, there. I don't care what else happened before. Exponent 0 gives 1.
So if it's bracket, then it's like a fraction of say like 1 over 2, and close bracket then the power of 0 is still be 1.
Yes, anything except 0. We'll just leave that on the shelf. 0 to the 0 is a big problem. How could it even happen? Calculus, we'll get there. So it's not gone, but for now we'll just ignore that situation and act like it can't possibly happen, but it can.
What if it's like 10 to the power of 2, like over like 3 to the power of like 2?
Mm-hmm.
It's like, because like, I don't know, the example that you put there was just like 3 and 5 and then over 3 and 5. Like, does it change anything or is it still?
If, after all this happens, if that's a 0, you'll get a 1 when it's over. I don't know if this is funny or not, and that's not a test hint. I'm not saying I will do that in a quiz or test. And it freaks people out when it happens. You're like, so after all that, exponent 0 just gives you 1? The answer is yes. 1 is the answer. Because something got divided by itself. Like, what if it's a giant number? What if it's like 10 to the power of 9, all to the exponent 0? The power of 0 says, oh, I'm dividing that, whatever your big number is, I'm dividing it by itself. Answer 1, always 1. Okay. Now negative exponents. I touched on negative exponents, and I'm hoping I can explain this in just the right way, where you go, oh, no problem, I understand it. Using it, that's trouble, but understanding it. So I'll do my table again. 3 to the exponent 3 equals 3 times 3 times 3, which is 27. 3 to the exponent 2 equals 3 times 3, which is 9. 3 to the exponent 1 is 3. 3 to the exponent 0 is 1. And this is a very clever, I didn't invent it, I'm not taking credit for it. This is a very clever way to figure out what exponent 0 means, and now what a negative exponent means. You see what my table is doing? 3, 2, 1, 0. Every step of the table, I divide by 3. So what does 3 to the negative 1 have to be? Weirdly. Totally weird that it would come out this way. 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. 1 divided by 3 is 1 over 3. If this was a truly, truly great private school where we could do with your time whatever we felt like, I'd just write that down, hand you an apple and a cookie, tell you to go sit under a tree for a couple hours and just think that over. Crunch. 3 to the negative 1 is 1 over 3. A negative exponent means, no, doesn't mean anything. It just means divide by whatever you're talking about here. So I'll do one more. 3 to the negative 2 is 1 over 3 squared. You just take that 3 to the 2 and it moves down to the denominator. That simple. Here it is in exponent law form. If you've got a to the negative m, you can put it down in the denominator and make it 1 over a to the m. Oh no, the dreaded comma. Except, in one situation, a can't be 0. This doesn't work if a is 0. If a is 0, you're dividing by 0, and there's a whole other discussion we have to have, which is going to go on for a while. Well, what do I do then if a is 0? Let's just careful. Let's stay in our lane for now. This slide is only supposed to give you the idea of negative exponents. What is going on is the number you're talking about, you should move it to the denominator. And if it's in the denominator, you should bring it to the numerator. That's coming later. I'm exactly halfway through the lesson. Scary. I'm not going to pause for questions there, because if you only sort of get the idea, that's the best I can do for now until I start doing the examples. Here we go. 7, 8. Oh, this is going to go quicker. I just have A, B, C, D, E to do it in examples. So we've got a chance here. This is the type of homework question and test question that stops people cold. Because this is a truly cat in the hat question. You've got to tie all this stuff together. Let's take a look at what we have. Negative 6x to the negative 2y, negative 9x to the negative 5y to the negative 2, 3x squared y to the negative 4. Here's Mr. Todd's big hint. I'm going to put it up here. You should write it down. Mr. Todd says, don't stress about negative exponents until the final answer. So the fact that they're negative is a stressful situation. There's negative exponents in this, and I say, well, don't worry about it too much. Don't get too excited about the situation until you get to the final answer. And then for one step, we'll go, okay, what are we going to do with these negative exponents? And when I show you, you're going to be underwhelmed. So for instance, the top, the numerator of this, negative 6 times negative 9. Maybe you need your calculator. But hopefully you can do that in your head. Positive 54. X to the negative 2, x to the negative 5. Same base, add the exponents. What's negative 2 plus negative 5? I don't know! Okay, chemistry people. If I have 2 electrons, and I add on 5 electrons, what do I have? 7 electrons. Oh, it's a negative exponent. No, no. Mr. Todd says, no stressing till the end. No stressing. It's like, okay, it's a negative exponent, no big deal. Next, y and y negative 2. Add the exponents. Ooh, what exponent's on y? 1. Add 1 and negative 2. Another negative exponent. I'm stressing. No, no, Miss Todd's saying no distressing. No stressing. So it's negative. No big deal. Not going to worry about it. Denominator 3x squared y to the negative 4. All brain power on now. If your brain has wandered away, better come back now, because this is virtually the same thing we were doing last week, except there's negatives involved. 54 divided by 3. Will that work? Maybe you'll need your calculator. Does 54 divided by 3 work? 18. Now, same base division. What do I do with the exponents? Subtract, but it's bad now. Negative 7 minus 2. In the middle of all this, you might want your calculator for these simple integer situations, because your brain's going to be working so hard on the exponent laws. You're going to see negative 7 minus 2, and you're going to go negative 7 minus 2, and you'll say positive 14 or something silly, because your brain is distracted. So you might want to, tonight, get your calculator back out. Negative 7 minus 2. Oh, that's negative 9. Ah, negative exponents. No stressing. No stressing. Relax about the negative exponents until the final answer, which I'm almost there. Then, negative 1 subtract negative 4. Good luck in your head, most of you. That probably will not go very well, but I'll try and do it. Negative 1 subtract negative 4 would be like negative 1 plus 4, so I get y cubed. And this is why I said don't stress about the negatives till the end, because it might not play out that you even have to deal with them. Some of them will come back to be positive, and then you're happy. Positive exponents are good. But this last one's got a negative exponent in there. Let me fast forward a couple of courses. During calculus, I'll be like, so do you see why we hate negative exponents? And you'll go, yes, I see now. For now, in grade 11, we tell you, no negative exponents. Get rid of the negative exponents. So I got to get rid of this negative exponents, and it's this simple.
You just put it over 1 and under 1.
Yeah, you just move it down. It comes down here. Whoops, yes? And it switches over to positive exponent. It was just in the wrong spot. That's a great way to think about it. Oh, it was just in the wrong spot. It was negative because I kept it in the numerator. If I move it to the denominator, it can be positive. And this is much better for us, is to have all positive exponents. Question?
Why don't we do like the foil thing, about like the 3 foil thing or whatever?
He asked the best question. Did you see me set all my stuff down?
What?
I'm hulking up here. I'm getting ready to say something great that hopefully you go, ah. Yeah. He says, why don't you distribute? Does anyone know from the gold writing I did that you all wrote down why we cannot distribute here?
Up to negative?
Not because the negative.
It's division.
Distribution is for when you're multiplying two things that are adding. There's no addition in the brackets here. He did it, and I didn't even rig it up. Did you see? I said, oh, he's going to go, oh, and he did. Like, ow. And in that moment, you're like, oh, this lesson's harder than I thought it was. All through that lesson, you're like, oh, yeah, it's no problem. Mr. Todd was worried. You got to be able to keep track and know when you can distribute. There's no distribution here because it's multiplying with multiplying. Distribution's for multiplying with adding or subtracting. You're like, oh, no. Now I see why I need a study page.
So it's not like 9 plus x, like...
No.
It's just one, it's like one big
This
number.
is 9 times x to the 5th times y to the negative 2. No distribution allowed. That's all one big piece. It's not adding two things together.
Oh.
Where's the brave question? Like, hold on then. Wait a second here. I'm getting upset. So what do I do if it is addition?
Then you do it.
And the answer is no distribution allowed. Here's what you're going to have to do. And there's none of these in your homework, I don't think. I'm not torturing you this yet, but you'd have to do this. And get ready. Distribute. Take whatever you have in that bracket. Distribute. Take whatever you have in that bracket, then distribute. There's going to be 4, 8, there's going to be like 16 terms that come out of this. So that's bad. That's bad. We're not doing that today. That's not what we're working on today. We're working on this. Other questions from that example? The dreaded comma. X can't be 0. Oh, you're going to get on about this, aren't you? Yeah, I'm going to have to. I'm going to have to keep talking about what x can't be. And actually, because of this negative exponent, I'm not going to get carried away with it just yet. Y can't be 0 either. But don't get distracted by this. This is 99% of the battle over here. This is just the 1% this for now, okay? When I'm on about this, you'll know. I'll get to this. I'm just mentioning it for now. I don't want your notes to have wrong things in them. But there. Stay over here. Don't stress about what's over here just yet. Okay. More time? It's going to be close. I think there's... Oh, okay, this isn't bad. And a good trick coming. You really want this down, this example down, so you see what happens. 2 over 5 to the negative 3. Good news. Good news. It's an exponent on division. We can just distribute. That would be it, except for the negative exponents.
Wouldn't you just have to move down the negative 3 and then it would just cancel each other out and you get like just, yeah.
And then this one,
Would just be canceled out or something?
it doesn't get canceled out. The 5 to the negative 3, the negative means it's in the wrong spot.
Oh, you gotta move it up?
Move it up.
So it just, oh.
Okay, so the way I've explained it, that final step is not too bad. Where you go, oh, okay, it just means a negative exponent in the final answer just means it's just got to move from the numerator to the denominator. Giving another potential way to do this question, I'll do this in purple. Some people will like this better. I'm not suggesting it, but they flip it right off the hop. They go, oh, okay, I know the negative means this, everything's in the wrong spot, so I could right now do this. I'm not suggesting this. This is not me saying, oh, and once you understand it better, you'll do it this way. No, no, I really like it this way. But some people will start to see it this way and go, I know what the negative's going to do anyways. It's going to flip this thing over. So I'm just going to do that right off the hop. So you could do that. That's a possibility. We should do a little better here, though. But nothing too spooky about the last step here, I don't think. You might get to be here for the day where I take this actor board and rip it off the wall. That'd be a story you could tell the rest of your life, the day I grabbed this thing by right here and just yanked it right off the wall, forcing them to get me a new one. You see it? Do you see it hitching when I'm writing? It hitches all the time. It's annoying. That's hard. So when you get to the homework and you have trouble with those, that is difficult to tie all those things together. That's like you're fanning with the fan, you're bouncing the ball, and then I throw you an extra bowling pin. You're like, oh, and then it all falls apart. Got to make plans tonight. Got to cancel plans tonight. Who's got the toughest plans to cancel tonight? Someone have tough plans to cancel? What time do you work? 4:45 to 11. 4:45. I don't know. I don't know, and I don't say this to pick on you. I really don't. I banned both my children from having jobs during fall and spring, like during the school year. If you have university level senior classes and you have some extracurriculars in your life of any description, a job is probably too much moving forward. It's going to wear you down. It's going to wear you down. The only thing I allowed was if it was a job that was like, it helped them. You know, there was somebody I taught last year who taught horseback riding lessons. And they know this makes me feel good. That's a good job to have. Trudging around no frills, making, what do they pay you an hour at no frills? What's minimum wage now? 15 something an hour? No, if you're taking university classes, you don't care about 15 something an hour. It's not worth it. You're on track to get a really great job. on this path. But mommy's making me work. Oh, you come talk to me. We'll talk about it, okay?
Oh, I got you. I got you as one. Yeah.
Hold on. He's so mostly right. He's so mostly right. Mr. Todd, don't change the rules. You said anything exponent 0 is 1. That's true. 7 to the power of 0 is 1. But then it's multiplied by a negative. That negative is out front. Let me do a side example just to help you. You might go, okay, now I get it now. That is 1. Because here the exponent goes first before the multiplication. It's just BEDMAS, actually. Your calculator knows, though. If you put it in brackets, this will come out to positive 1. This will come out to negative 1. Because this one says go power of 0, then multiply by negative 1. This one says multiply by negative 1, then go power of 0. So it depends on which order that is. A little quirky one there. I know. It's tough, right? Middle of that, little cooking oil on the floor while you're trying to balance all these things. Yeah? Your calculator knows, though. If you punch in your calculator will tell you, and then you can stare at your calculator and go, ooh, unless you're at work all night and you don't have time for it. Where do you work? Dairy. Oh. Perfect. It's the perfect job. It's the perfect job. Seasonal jobs are good, the ones that go into September. A little bit extra time, no problem. Great stuff. If you have other heavy jobs, don't get upset that I said that about jobs. Just come and see me and we'll talk about it. We'll talk about balancing these things. You know, balancing the job you have with, when does yours close? Oh yeah, it is Thanksgiving. They always put the sign up. Come in before Thanksgiving. Yeah, okay. Negative 7 to the 0. This one is 1. Negative exponent. Negative exponent. Actually, there's more to negative exponents than what I'm saying. But this is a great way to understand negative exponents. Negative exponents means it's in the wrong part of the fraction. That's the only reason it's negative. It's in the wrong part of the fraction. So we can bring that piece up and make it 3 to the positive 2. This has answer 9. And your calculator will know the answer, by the way. So calculator, big help. If you, in your calculator, type negative 7 to the 0 over 3 to the negative 2 and press equals, it'll say 9. On my test, you'll get 0 marks for writing down 9. I need to see the steps, but it does make you feel good that, yes, I've got it down pat. I know what's going on. Tough set of homework. You might not actually finish this homework. You'll have time to get through the homework, but there'll be answers where it's like, I can't get the answer they got. Don't work on it all night, pounding your head in the desk and going through a whole box of Kleenex crying about it. Just highlight the ones that you had trouble with, bring them to me tomorrow, and I'll go through, oh, well, this is a 5. You're like, oh, I get that now, okay? Am I going to make it? How many do I got left? Oh, last one. Somehow I made it. Last one. It's a big problem. Because they can't move. Because of this. It's not a regular exponent type question because of the adding or subtracting. So, I asked you to come in today, fan with the fan, bouncing the ball, then I put a little cooking oil in the room, and then I just took, this is the earthquake question. Now there's an earthquake going on, shaking the whole house. That addition takes all the exponent laws and goes, oh, but sorry, you can't use any of your exponent laws. You're like, well, what am I supposed to do? Okay, one at a time. Check this out. Big problem. And if you're not there yet, this is that example at the end of math class sometimes that you're like, you know what, I'll just write it down. I'll try the rest of the homework, and then when I get to these ones, then I'll try and address that later in the evening. Or I'll text Mr. Todd, or I'll rewatch the video. I can deal with them individually, though. 2 to the negative 4 is 1 over 2 to the 4. And 2 to the negative 6 is 1 over 2 to the 6th. Individually, I can put them into the denominator. Separate denominators. And if right now you're thinking, really, Mr. Todd? The answer is yes. Really? And I can deal with each of those individually. 1 over 16 plus 1 over, it's 64. How do I know it's 64? Oh, it's, okay. 2, 4, 8, 16, 32, 64. And this is 1 over 8. Now just get ready here. If you have even 1% of your brain left after this long lesson, listen to this sentence. When it's multiply, combine them's easy. Combining fractions, exponents, anything else. When it's adding, it's a big problem. What do I need to add fractions? A common denominator. You're like, what? Are you serious? In the middle of all this, common denominator? Dead serious. Here's the extra steps. I'll write them all down and then give you a chance to look at them and either go, oh yeah, I get that, or go, wait a minute, I got to talk about it with 10 minutes left. It's good timing. Let's see. It'd be 4 over 64 plus 1 over 64 all over 1 over 8. Which is 5 over 64 divided by 1 over 8, which I'm going to write in a way that might actually help you. 5 over 64 divided by 1 over 8. Equals 5 over 64 times 8 over 1, which is 40 over 64. Those both divide by 8, and I get 5 over 8. Oh, mama. That is a mama. And you look at that second column and you tell me, not if you have questions, I'm sure most of you have questions about what I did in that second column. Which line would you like me to talk about? Because some of it you might actually remember. You might actually remember that fraction stuff. But grade 10 academic doesn't ask you to do very much fractions. A little tiny bit of fractions. So you might be really rusty on that type of stuff. Notice how many examples I did though. Did I do like 14 examples today? Including the ones that were in the lesson before I got to this. This is not the core of the lesson. Don't leave this and go, oh, I'm going to fail 11U. I don't know. Just one of the examples. Question? Yeah, dividing by fractions, we multiply by the reciprocal. That was our dividing by fractions thing. But that, I don't know if it comes up in 10 academic at all. That might be all the way back in grade 9, and you guys did de-streamed. So you might not have done as much fraction work as we wish you would have. That's okay. It'll be okay. This will not decide your fate. This will not decide whether you get a great mark in this class or not. Find a way. Address this homework. And for those of you who aren't taking notes in class, you're making a mistake. Get some paper out. No, I just like to sit back and soak in the lesson. No. You better copy this down. There's learning to be had while you're copying. And those of you on videos, watching this on video, get a piece of paper out and copy this down as you're going. That's how we learn.